Problem 3 is asking me to evaluate a piecewise function. The first thing that it asks me to do in 3a is to sketch a graph of the piecewise function and then use the graph to answer the other questions. So I'm going to take a look at the 3 pieces that I have, and I find it helpful to make an XY table for each of the 3 pieces. So the first piece is negative x plus 1, and my x values have to be less than negative 1, so I could use negative 3, negative 2, negative 1, and recognize I'm going to use an open dot at negative 1. So if I substitute in these x values into my function for x, I would get negative negative 3 plus 1, which is 3 plus 1 is 4. Negative 2 is 2 plus 1 is 3. Negative 1 is 1 plus 1 is 2. So I can go here and I can, at negative 1, put an open dot at 2. At negative 2, I can put a dot at 3, negative 3, a dot at 4, and I can connect my dots and finish them off with an arrow. And there should be a nice open dot here. Okay. My next function is x squared, and I can use values from negative 2 to 2. And I end up getting my outputs, and I can certainly put those outputs on my table or my graph here using closed dots for my ends. And then my last piece is x plus 2, and I can use anything. Actually, now you notice this should be an open dot, not positive 2. Because this is going to be a closed dot on the x plus 2 portion of the function, so I can do 2, 3, 4. 2 plus 2 is 4, 3 plus 2 is 5, 4 plus 2 is 6. So I can plot these points. Alright, so then 3b is asking me to evaluate f of 2. Well, f of 2 exists in this third function. If I substitute 2 in, I get 2 plus 2 is 4. 3c is asking me to evaluate f of negative 1. Negative 1 exists in this second function here. So if I substitute in negative 1, I get out that x squared is positive 1. 3d is asking me for what x values does the function equal 0. There's only one place, and that is at 0, 0. So g of x equals 0 at x equals 0. 3e is asking me for what interval is x greater than 0, and that is everything. So g of x is greater than 0 from negative 0 or negative infinity to infinity.